All right, good morning. What a full room. And they tell me security is boring. I don't believe them anymore. Hi, everyone. I'm Daniel. I am a software engineer. I work for Broadcom in the Spring team, Spring Commercial. We do package Spring products that we sell to our customers. And I also do quite a bit of open source, mostly in the security space. So Spring Security, Spring Authorization Server, and lately, everyone is doing AI, so I'm doing security for AI as well. You can find all my contact information over there, right? So I'm on Blue Sky, I'm on the internet, I am on Twitter, I'm not on Twitter anymore. Scrap that, no Twitter. I'm on GitHub, I'm on LinkedIn, can find me by email. So, if you have Spring security related questions, come to me. Chat with me in the hallway. I'll be happy to have a discussion with you. Otherwise, send me an email. I'll take the time to answer that. So the program for today is passwords, or more likely, lack of passwords. So it's 2025. So I probably don't need to convince you that passwords are not great. So it's not the passwords themselves. It's the practices that people have around passwords. Who here reuses a password between websites? Don't be ashamed. I do. That's not good. No. So if you have good password hygiene, use a password manager, you should be fine. But most people don't do that. And so the idea is, can we get rid of passwords and still have a good user experience? It's been possible for a long time. So today we're going to talk about passkeys. That's the title of the talk. But do you know any other ways to do a login without a password? Any idea? Yeah, go ahead. Shout. Yeah, one-time token. We have one-time passwords as well with authenticator stuff. So in Spring Security, we have support for one-time token. So I have an app here, and this app has a form login, and we said this one has a password, and we said no password. So now in Spring Security, it's been a year now that we shipped this. You can remove your form login. Is the font size okay for everyone? Yeah. So in here, boo, passwords, thumbs down. Don't do that. No. So instead now, you can do something like one-time token, OTT login, and you configure it. And there's one thing to configure. So Spring Security will put in place all the infrastructure for you for generating token. But once a token is generated for a user, you have to do something with that token. So you have to send them to the user, basically. So in here, we do OTT login, token generation success handler. So when a token is successfully generated, then this takes a Lambda, takes a request, a response, and then a one-time token. Okay. And in here, you can handle it. So we give you a redirect one-time token handler just to redirect the user to the page where they can put their token. So you can redirect them to login OTT. That's the default. Let's make a field out of this. Sure. It's here. Redirect. Call it maybe default handler. That's the default that Spring Security give you. Default handler. All right. And handle, request, response, one-time token. But you also need to send the token to the user. So we're going to extract that token and send it. So the one-time token object here has a token value. That's the token we want to send. And then it also has the user identity because we want to send the token to the correct person. So in here, we can grab the username. I use the email as the username, so it's easy. So we could print into the console maybe a cookie represents a token. Cookie. There we go. Got token for blah, right? And maybe format with so the token is the token value here, and the email is this. In reality, I think you don't give access to the logs of your production application to your user, so you probably want to send that over email or SMS or something. So in here we do one-time token. Maybe we have a mail notifier. So I created a thing that sends an email. So send an email. Notify the user. So the address of the user is the email. And then I can put a title, login to cool OTT demo, right? And then you pass the token. So this is left as an exercise for you. It's your use case. It's your email template and so on. So with that, this should have recompiled. And now I have a different form. No passwords. Good. I can put my username, which is an email. So daniel@example.com, right? And then send that. And so a token is sent in here. I can see a notification in my totally real mail server. So in here, I get an email. This is the template I created. You try to log in, use this link or use this token value that we have here. I can click, sign in, and boom, I'm logged in. No password. Very good. Interestingly, I got a token in the email. So if I try and put it here and try and log in again, then I get rejected because it is a one-time token, not a two-time token. So, it works as expected. It's cool. It's easy. Two things with this. The flow is not great. If I receive the one-time token on my phone and I'm trying to log in into my laptop, then I have to copy the stuff. So a bit painful. We would like something better. Also, you come to DevOps not to learn about 1998 technology, email, right? You want something exciting. So now we have this cool new thing. Well, it's been 5 years now, called Passkeys. So who knows what Passkeys are in the room? Oh, that's a good 30–40% of the room. And who actually uses Passkeys? Hey, the same people, probably 20%. So I want to show you how this Passkeys work before implementing it. So let's close our app here. Good. So I have GitHub here, and I'm going to open it in private mode, actually. GitHub.com. I use Passkeys all the time, and I use it to log in to my work stuff, to my email, to my GitHub. And you're developers, you probably use GitHub, so I can show you this. So on the left here is GitHub, and then on the right is my phone filming my computer. And now it's filming you all. Say hi. Hi! Amazing. Great audience. I'll give you 5 stars. So in here, if I try to log into GitHub, I could log in with my email, right? Something like that. And then I would have to put my password. But if I do this, then I have to check a second factor. It's a bit painful. Also, we said, we don't want to use passwords. So in here, there's a little link that says sign in with a passkey. And when I click it, a pop-up comes out. This is a macOS pop-up, but you'll have the same thing on Windows with the different colors and style, but the same idea. And it says, you will be signed in to github.com with your passkey for the account called Galant, which is my GitHub email. So if I zoom out here, and I take my fingerprint here, and I put it on the fingerprint reader of the Mac, it unlocks the Mac. The Mac loads a passkey, and then does some crypto magic, and proves my identity to GitHub. By doing that, I have logged in with 2 factors at once. It's something I am and something I have, my Mac, right? So this is one way. Second way is possibly, if you don't want to be using biometrics on your Mac, for example, you can use hardware devices. So when I click here on sign in with a passkey, here are some USB keys and they start blinking. This is a UB key. Right, and this can hold a passkey as well. So I can click it, and then I need a PIN. So if you steal my UB key, you still need my super secret password to log into GitHub. Click again, and then I get logged in. The third way is if you use a password manager, because this platform stuff, on Linux it works with a UB key, but like fingerprint reader on Linux, not great. So what you would do instead is use a password manager. Password managers can store your passkeys as well. And they're actually pretty smart. They detect that you can sign in with a passkey, and they propose to say, do you want to sign in using your passkey? Sure, 1 click, and then I get signed in. And then the last one is my favorite one, is the most fun one of those, although not necessarily the most convenient. Suppose I go to a public library, and I want to sign in another computer, but I don't trust their computer typing my password, because maybe it has a keylogger installed. So I want to use a passkey. I could use my UB key, or if the computer has Bluetooth and is connected to the internet, obviously, then I can click more options on this one, and I can say iPhone, iPad, or Android device. So use a passkey that is stored on one of your devices nearby, and use that to log in. So I do this. I'm going to point my camera at this QR code. Now, the iPhone and the computer will detect each other's presence using Bluetooth, just to be sure that not someone in Paris right now is trying to log in with my phone. And then they establish a secure connection over the internet. And then I can choose on my phone, I want to log in with a passkey. So I have 2 passkeys for GitHub on this phone. I'm going to use the one from the phone. Then it asks for Face ID at the bottom here, meaning I have to unlock it with biometrics. I unlock my phone does the crypto magic, sends that to the computer, and then the computer logs me in to GitHub. Right. So this is passkey login in general. Now, before we get into the details of how it works, a little glossary of the terms we might use. So a passkey is a crypto credential, and that crypto credential is tied to an account, so my GitHub account, on a website, github.com. I can't use it on another website. So if I go to amazon.com, I can't reuse the same passkey. I have to create a new one. An authenticator is the thing that holds my private credentials, my private keys. So in this demo, we've seen my Mac. My phone has private keys. My YubiKey has private keys in them. And then it can also be a software thing, like my password manager. And then sometimes you hear about FIDO, FIDO2. So FIDO is Fast Identity Online. It's a consortium of companies that want you to be able to log in easily. Started with the big ones, Apple, Google, Microsoft, but now there's many, many more. Oops, come back here. There we go. There's many, many more, right? We have Amazon. Well, of course, we have the password managers, but we also have, I don't know, Netflix and Rakuten and some banks. And so everyone wants you to log in securely and easily. They produce 2 specs. They produce WebAuthn and CTAP. CTAP is the client to authenticator protocol. So is how does your Mac or how does Chrome talk to the phone to do the crypto? So probably in this room, not many of you are going to be implementing an iPhone, so you don't really care about CTAP. WebAuthn is the JavaScript you put in your browser to trigger these passkeys flows, and it specifies how you verify the passkey signatures in your backend application. So it's a spec. It's a W3C spec, the usual delightful reads that you take to get a good night's sleep. So it has, it has code examples, and then if you scroll down, down, and down, and down far enough, you get some diagrams, and then you get, type definitions and so on. And zoom out. If I try and print this to put on my bedside table, right? I have not read all 288 pages. We don't want you to be reading this. This is super complicated. The idea of this is for us implementers, so for Spring Security, for the browsers, we agree on what it works to do passkeys, and then with that, you can log in securely by using a library. All right? So how do these passkeys things work? They work with crypto. So public, private key cryptography. So, it's the basic stuff, right? So Alice generates a key pair, so a private key that she keeps. Private! Very good. And a public key then she can distribute to the outside world. So on my phone, a private key is created, and then I send the public key to github.com. And then in the future, when I want to prove my identity, I get some content, any content, stream of bytes. Using the private key, Alice can sign that content, so create some more bytes. And those bytes are tightly linked to her private key. And so if she sends that content along with the signature, then third parties using the public key can say, yes, the signature matches. This signature was produced by Alice. If an attacker comes in, tries to generate a signature, either a random signature or a signature with a wrong private key, then the signatures don't match, and then the third party can reject that. GitHub can say, nope, that's not Daniel. So with that private key, you do 2 things. First, you register it. So you have to have an account on github.com, and then you say, I want to add a passkey there. It's going to create a private key, store it on the device, and then share the public key with github.com. That private key in my device is tied to github.com. If I go to amazon.com, my device will not try to use this. So this is phishing resistant. I cannot type the wrong password. So I could type the wrong password, but I cannot use the wrong passkey on the wrong website. The way this looks on GitHub again, in here, you go to your settings, here, and then you go to passwords. Here, passwords and authentication. And in here, you have passkeys. See, I am a very security conscious, crazy dude. I have 5 passkeys. So here's the details of what you can do. And you can add a passkey, and the same kind of pop-up will come out and say, do you want to register a passkey? Do you want to update the passkey? Do you want, what do you want to do? So that's when you register a passkey. Then when you come back, so now GitHub has your public key or public keys. When you come back, you can use your device. It uses the private key, produces a signature. You send that signature to GitHub, and then GitHub checks the signature against the public key that it has for you. And then if it matches, it means it's you. You've proved your possession of a private key. You are logged in. So let's see these flows in practice. There's 2 flows, registration and authentication. So the first is registration, when you add a passkey. So if you go to the spec, you get these kinds of delightful diagrams you have to find. So it starts with 0, but that's grayed out for some reason, and it goes like this, and then you're finished. So everything here is correct, but not necessarily great for explaining. Instead, I like to make sequence diagrams. So we have 4 parties in that passkey registration phase. First, there's me, the user. I want to register a passkey. There's the website I want to register a passkey with, so github.com. Then the browser I use to go to github.com, and then the authenticator, so the thing that is going to generate a passkey. I'm going to go to GitHub and then click Add a passkey, and then a pop-up comes up. And before that pop-up comes out, the GitHub says, OK, you want to register a passkey. I'm going to create a challenge. And challenge is a random string. The idea here is that we're going to sign something. If someone finds that signature in the future, I want them to not be able to reuse it. So every time I do something with a passkey, a new challenge is issued. GitHub knows that the challenge is like 1, 2, 3. So if someone sends them an old signature of the previous challenge, which was, 987, then it doesn't match. So it generates a challenge, sends that to the browser. So the browser gets the challenge, and then the browser calls the public key credentials API, and it says create. So create a passkey. You can pass a ton of options, but most importantly, you must pass the challenge. And this is what wakes up the pop-up. So then I select an authenticator, and the authenticator says, do you really want to create a passkey? And then it starts asking for verification. So maybe the phone says, oh, this will create a passkey with that username on that website. Maybe the YubiKey starts blinking. I have to do something with it. I have to touch the YubiKey and then unlock it. Some devices, I have some here that have no password, but I still need to at least interact with them. I need to click. I need to be present. The idea is that we don't want the websites to start hammering our passkey to try and do a denial of service or exploit a flaw. So in here, only one passkey ceremony happening at a time, and I have to physically do something with it. So I click my YubiKey, I put my PIN, or I do biometrics. That means I agree with that creation of that passkey. So the authenticator generates a public key or private key, keeps the private key on the secure storage. Then it signs the challenge with that private key, and then it sends the signature and the challenge back to the response to that credentials create. So the response to that function contains the public key and the signed challenge. Then we send that to the server, and then the server verifies that the challenge matches the signature, or the signature matches the challenge using the public key you've sent. That everything goes well together. If that's the case, then it stores the public key, and so now then I can reuse it in the future. Now, all of this is a lot of steps, and it's a bit scary, but the good news is that everything that is on the right here, you don't have to implement. So authenticate the user, you don't implement your users, I think. Authenticator, you're not going to implement an iPhone or YubiKey, so you don't have to do this. You have to care about stuff that happens on the server and in the browser. So in here, we're doing this with Spring. So on the server is going to be Java. But it could be in any other language that has support for passkeys. So I think the reference implementation is in Rust. There's libraries in Go. There's library in PHP. I'm pretty sure there's library for any major programming language that does web stuff. In the browser, it's JavaScript, or anything that compiles down to JavaScript, because you're calling browser APIs. So There is no way around it. In the Spring security team, we were very happy to write a lot of JavaScript for this. So that's the registration phase. The authentication phase, so using your passkey to log in, exactly the same thing. But instead of calling credentials create, you call credentials.get. We're not creating a new passkey. We are verifying the identity by obtaining a signature. And so instead of creating the private key internally, it loads the private key, it signs the challenge, returns the signed challenge, and now the server can verify the signature. And by verifying the signature, say, yep, that's Daniel. Oh, no, I don't know this person. Do not log them in. OK. Blah, 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 lots of talk. We're going to do a little bit of demo. But before the demo, I want to reiterate, because I always get this question after this talk. Passkeys are not biometric. Passkeys have nothing to do with biometric in itself. They're just private keys that are stored somewhere. So they're crypto private keys. They have some metadata associated with it. So maybe my username, the account name that passkey is used for, and maybe the website against it, not maybe, the website against which I can use it. And that's it, right? Even if I created it with my phone with my face, it's just a private key. That private key happens to be stored somewhere. So it can be on my phone, it can be in a YubiKey, my Mac, in a password manager. It's stored in a secure device or software location. And it so happens that to unlock this device, maybe I use biometrics. But the biometrics is local to my machine. So when I log in with GitHub with my face, what's happening is not sending my face data to GitHub or my fingerprint data to GitHub. It's using my face locally on the phone to unlock the secure enclave where my private key is stored, and then unlocks the phone, basically, unlocks the private key, signs the challenge, and then sends the signature. So only crypto private keys are used, no biometrics. And sometimes these passkeys, they're synced in the cloud. So when you use a password manager, of course, the goal of a password manager is most of the time to sync your stuff. So of course, this is synced across devices through the password manager. If you're in the Apple ecosystem, you can create a passkey on your phone and have it synced to your laptop. And then maybe on your laptop, you use your finger to unlock it, but it's just because it's a copy, right? So it's syncing. If you use a YubiKey here, this does not sync. It's local to the device. So if I lose this one, I cannot use the passkey anymore. So if you're only using YubiKeys, their recommendation is buy 2 of those, and then you register 2 on the website. So if you lose one, you can log in with the other one, which is very convenient for someone whose business is selling devices. Buy 2 at a time. All right. So, a little bit of code. Let's do this. So how do you do it in Spring Security? Well, as I've mentioned in some previous talks, you go to Josh's 3rd favorite place on the internet. So what's the second one? What's the first one? What's the first one? Production. Yes. What's the second? Spring initialize. 3rd, the Spring.io. But secretly, what he really likes, and he doesn't tell you, is docs.spring.io. So we go to the Spring Security documentation, Spring Security. And then in here, you can look for passkeys. Amazing. And so in here, you have all the details of what you need to do to get passkeys. So what you need to configure, the details of the payloads we send to the browsers and so on. But most importantly, it starts with you need a dependency. So you need to add this com WebAuthn for J dependency, which is the library that does all the hard part of verifying the signature and creating the objects and so on. We do the glue between your browser, so your web API, and WebAuthn for J. So let's add this, I think. Let's see, do I have it in my build already? Build.gradle. Here we go, so it's not here. Implementation, this, recompile. Network at DevOps, let's go. Let's go, network, you can do it. So while this is compiling, let's see what we have to do with this. So this is just going to be for the signing. So, haha, so easy, first try. All right, try this again. Restart the application. And now I configure my Spring application to use passkeys. So in here, I do .WebAuthn, because it's the WebAuthn spec. If you're contrarian, you can call the Lambda passkeys instead. And in here, you need to configure a few things. So a few things are required. So the first one is the RP ID. The RP ID is the identity of the website. It's the domain. So in here, our app runs on localhost. It could be, it's functionally equivalent to the domain on which this runs. So in the GitHub example, this would be github.com. Then you need to set the allowed origins, because sometimes you want to use the same passkeys on multiple domains. You want this to be allowed. So for example, say I want to use my Amazon passkey that I created on amazon.fr. I also want to be able to use it on amazon.com and amazon.co.uk and amazon.de. And is there an amazon.be? Yeah? .com.be, right? So in here, you say all the websites on which you can use that passkey. So in here, detail is localhost 8080. This is where my app runs. And then the last thing is the RP name, so the name of my website. So Spring Security Demo. And what's really fun is that if you go to the spec, this is now deprecated, but required. So the idea is that in the original spec, we wanted to show a pop-up and say, oh, this is the Spring Security Demo website. And it turns out nobody implemented that. So they only show you the website. So you still have to put it, but it's not displayed. So in the future, we'll probably make this optional. And with that, if I, well, this actually recompiles all the time. It should be fine. If I go back to localhost, let's make a private localhost 8080, I now have a new button that comes in the default Spring Security login page. And when I click on it, it says sign in with a passkey. There's one important detail here. I'm not adding a passkey right now because this, let's do a warning. Warning. This is all in memory, right? Because by default, we don't know where you want to store your passkeys. So we put them in memory. So every time you restart your app, if someone has created a passkey, they've given you the public key. They have the private key on their device. And then the app restarts, you lose the public key, and they can't log in anymore. So not great. You do have to provide something. You have to store these public keys somewhere. So in Spring Security, there's some representation of user. It doesn't necessarily have to be user details, but it's someone who's trying to log in. So we know there's a user and they have a username or a string representation of who they are. So this already exists. This is not passkey specific. This is your app. You need to provide two tables, the credential record table, which is where we're going to store the public key. So the public key is going to be in this attestation object, and then some metadata. So the label, the identity of the key, and so on. And then some table to link these two together. Fortunately, to make this easier for you, we provide some JDBC implementations. So Bean, we have the user credential repository. So this is the passkeys repo. Return new JDBC user credential repository takes JDBC operations, right? And then the link table. So Bean public. Come on. Yeah, here we go. Public key credential user entity Java naming. Oh my God. There we go. And then return a new JDBC public key representation repository. Sorry, also takes JDBC operations. JDBC. Oh, IntelliJ. There we go. And with that, you store the passkeys in a JDBC database. So I have a Postgres running. And so now I can risk having passkeys. So I do this. I'm going to put my email, daniel@example.com. Okay, so I get an email in my console output. Here we go. I can paste that. I can sign in. Now I need to go to the default passkey registration page. So let's do in the index here, you're logged in, and then do a paragraph, add a new, and then href. This is WebAuthn, register passkey. Right, and then we come here, and then we get the Spring Security default page for registering a passkey. I give it a name, so I can find which one it is if I want to remove it. So Touch ID, that's my Mac. So pop-up comes, let me cancel it. Here we go. Oh, try again. So Touch ID, that's my Mac. So in here, again, I can use my finger, put it in the fingerprint reader, verifies my fingerprint, creates a private key, public key sends that to the Spring app, and then the Spring app saves it. And then I'm going to add another one, Thetis here. It's another physical device that I have here, so I can select it. Let's say more options, come on. Security key, continue, so you can see it can start blinking here. So this one I have to click it, but I have not put a pin on that device. So in the hallway, if you're a pickpocket and you steal that from me, you will be able to log in to localhost on my machine. I know, scary, scary. And so, go back, we sign out, and then we sign in with a passkey. Again, pop-up comes in, I can use my fingerprint, then I get logged in, right? And then I can use any passkey that I have. So in here, Thetis starts blinking, click, and then I get signed in, right? So in here, I told you I have the database ready. It's not, it's not magic. It's not hard to find. If you go at look at the Java doc for these JDBC implementations in here, you will see this depends on the table definition in ClassPath org, Spring Framework, security, user credentials, schema. So here we go. We want the file. So you can go in this one. Right, and so here's the schema that you want to use. So we have it. I have it for Postgres already. And so in that schema, there's a few things. So there's the identifier of the key. So when the browser sends the signature, it also sends also its key 123, so it can know it's Daniel's key. It has the foreign key for the user to know it's Daniel, and it has an attestation object. So the attestation object is where all the data about the passkey is actually stored, and WebAuthn for J works on these. I am not going to give you the details of the attestation object because it comes from the spec, and I mean, well, so this is compact binary object representation, CBOR, that contains data, and it contains a COSE key, which is a CBOR, so I put some CBOR inside your CBOR. Parsing this, I've tried parsing this manually by hand, but I gave up. So it's in here. We trust WebAuthn for J. We have some metadata to show it in the page, and we have also extracted the stuff that is inside that attestation object so that you can access it as a developer if you want to make decisions. Because, is this a passkey that is synced to the cloud? Is it a passkey where the user have to prove their identity with a PIN or with a biometric or something? So it's already in the database here. With the JDBC implementation, it must match that. All right. So now you have the default experience with Spring Security. You have beautiful, beautiful default pages. But in your company, you probably want your own user experience. So if this is an internal portal, nobody really cares. It's fine if you use the default Spring Security website. If this is user-facing, that is not that's not on par with the brand of what you have. So you need to create your own page. So let's do that. I have a passkey controller here, so I have a login page. And so that login page only has a button, so you can take a look at it. It's called custom login. Here we go. See, I'm very good at CSS. That's why they ask me to do it in the team. So let's style it, right? First, before we do the security, we must have the branding. That's what's important. So we have this signing passkey button. Maybe we set a font size to 2 rem, and then maybe we set a font weight to bold, right? A bit flashy, and then maybe we put some padding in the button to rem, right? We have to use the correct font family that matches what we use in the company: Comic, Sans MS, and sans serif, right? And then, this is already good, I think. This is not bad, getting better. But it's a little bit sad. So let's set a background, and this is going to be a linear gradient to top right, and then orange to, orange to aqua. Yeah, no semicolon. Here we go. And gorgeous. See? Ooh. Okay, Great. CSS. Now we want the JavaScript because this doesn't do anything. Not great. So let's write a little bit of JavaScript. In here, I have to write some script. And this is a timeleaf template, so I'm going to do some timeleaf magic that we'll discuss later on. So what do I want to do? When I click on the button, I want something to happen. So document, add event listener, DOM, content loaded, right? And so when the page is ready and it's all rendered or all gotten from the server, then we can get the element by ID, our signing passkey here, and then to that we're going to add an event listener on click. We have an async function. Right, and what does that do? For now, let's see if I have broken my JavaScript. Alert, DevOps is cool. Thumbs up. Right, so is my JavaScript still good? Hey, first try, amazing. So now the hard part begins. Passkey stuff. So you have two ways. You have the hardcore part. So you go to the spec. And then you go to the, so in the introduction, there's a sample API, zoom out, come on. Sample API usage scenarios and then authentication. So you can click here and they will give you the code that you need to use. So authentication, this looks okay. If you go to registration, then suddenly it looks more interesting. So that's the hardcore part. If you're like me and you are a 10x developer, meaning you copy paste a lot, you go to the main page that we have, because in here I can go to the debugger in Firefox, and then there's a beautiful WebAuthn.js. So you can go here, and then you take this, and then you find all the way to the authenticate method. Great, I'm going to take that one. Right, there's a register method, which, okay, I don't need that one yet. Take it, and then, amazing, put this here. Right, and now in here I can await authenticate, right? Easy. So that code is open source. This is, if you go to the Spring Security website, Spring Security project, and then you look for WebAuthn, or anything that's .js, actually, there's not a lot. WebAuthn, oh, that's the branches, come on. Ah, it doesn't want to search, there we go. WebAuthn core.js. I think maybe just .js should work, right? There's not a few, right? So WebAuthn stuff. You can go to WebAuthn core and you can take these JavaScript lines and bundle them in your application. Copy paste is fine. So now we have to call this authenticate method. So what do we call? We have to pass some headers. Let's think about that later. The context path, so my app runs on the root, and then conditional mediation is a Boolean, and this is about, you know, trying to help your password manager detect there's a passkey. We don't care about that for now. In here, we have some headers to pass. If you're not sure what you're supposed to pass, you can look at the main page again. So let's go to the inspector, and in the head, in the script, expand the script. Let's make this better. All right. And so you can see we have to add a header called xcsref login, csref, the bane of your existence. So you can do it with timeleaf. If I remember this is csrf.get header name, right? And then we put some value here. csrf get token. I think that's right. Let's see. Go into the main page here. Cool. And then our script should have the csref values here, right? So this is what you should be doing. Oftentimes, I come to your companies, and you're here, and you're like, well, csref is complicated. csref, this configure, disable. Oh, no. Scream. Don't do that. Makes me sad. Also, it's not very secure. There are ways to do this, so go read the reference documentation of Spring Security about csref. You will find all the answers to your question. And so we go to the login again. So we have this authenticate function, and as you can see, the response that the Spring Security server sends you is a redirect URL. So in here, we can say, okay, sure, I'll grab this const redirect URL, and then in here, window.location.href equals the redirect URL. All right. And so now, with this, if I click here, hopefully, it's not working. Network error. Oh, because it's building. Sure, fine. Poop. Pop-up comes in. So the passkey pop-up. Let's cancel. Try again so we can see it. So pop-up comes in. My passkeys start blinking. And I can click here, and I get logged in. Right? So with that, you should be able to implement your own passkey flow. On the server, if you have custom needs and you want to say, I want only passkeys of a certain type. I want passkeys that are not backed up to the cloud. I want passkeys that prove the user identity. We have an abstraction, WebAuthn, relying party operations, and we use WebAuthn for J. If you want to implement the interface, that's up to you. I would recommend using the one that uses WebAuthn for J, because if you look at the details, there's a validate somewhere here. WebAuthn manager validate here. So we call into this WebAuthn manager, and this one calls verify, which calls verify, which calls parse, and then calls verify. Welcome to Java, verify. And then very deep down at the bottom, we get to the interesting bits where all the checks that come from the spec. So it took the spec, and they took the steps from the spec, and some of this is on the browser, and then on the server side, everything that needs to be checked is checked one by one. So, oh, I need to verify, I don't know, server property, authenticator data, and then I need to verify this. So poof goes into here, and there's a bunch of stuff to verify. And then step number 13, I verify the RP identity, and step number 19, and 25, and all the way to step 28. So as you go, we add more and more steps. So you don't want to be doing that manually. You delegate to WebAuthn for J. All right. So because otherwise you're parsing this, and that is not a good idea. All right. So we're reaching the end. A few observations. As you may have noticed, this is a little bit complicated, non-trivial. If possible, even this JavaScript, right? That's a lot of JavaScript. If possible, you let your identity provider handle it. So your internal identity provider, you have a company keycloak deployed, and you go talk to your keycloak admins, and you say, can you please check the passkeys checkbox so that it's turned on? If you're using Okta or Azure Entra ID or Ping Identity or whatever identity provider you have, let them do the hard part. They manage your users, they will manage the passkeys, and they will do the checking for you. If you really have to implement it locally, then use a library. So you will use Spring Security, and as you've seen, it's still a little bit complicated. Lastly, with Spring Security, we have support. So now we're reaching Spring Security 7, so this is well supported. You can contribute to this. So if you go on the Spring Security project, you can go to the issues here, right? No, not this one. No, here. Spring Security. This is, come on, Spring Security. Here, cool, I'm already logged in this thing. So Spring, security. Here we go. I'm not gonna log in, whatever. So in here, you can look up the WebAuthn issues, right? So if you have a problem, create a new one. If you are interested in something, go look up the issues and then put a thumbs up on the thing that you care about, because that's information for us to go and decide what we implement next, right? So contribution is code, but even more than code, it's participating in the community and, responding to issues, helping us with issues. If you want to learn more, so this was, 45 minutes, you can go to Ubico's website. Ubico's, they're the people who make the YubiKeys. They have a passkeys section. So on developers.ubico.com, they will tell you how passkeys work, like what we did, but has much more detail on all the things. And if you're implementing stuff, there's a WebAuthn developer guide, and it will tell you, oh, here's how you do authentication. So you have to do this kind of JavaScript, and then it comes from the server and that way and that way. So if you really want to learn deeply how it works, then here it is. And lastly, if you want the sample for this demo, it's on GitHub. Reach out on the internet. And as I always tell you at the end of my security-related talks, when a stranger gives you a giant QR code on a cinema screen, what do? You scan it, right? What could go wrong? Do you trust me? This is fine. This is just the feedback form for the session here. So very easy. You take 5 seconds plus the network, and you can go here and then rate it. And if you take 20 seconds to tell me what was good, what was not so good, what you understood, what was missing, only 3 people fled in horror, and they mostly laughed at my jokes, right? And then you send me that feedback. I will do a better section in time. If you're lazy, you don't want to do this, just rate the talk. Don't let anyone influence you on knowing what you should be rating it. Just whatever's on your mind. And with that, I thank you for your attention, and I hope to chat with you in the hallways. Thank you very much.